Welcome to Jewel Academy, where learning becomes much more easier. Today we'll be discussing on the gas laws. Before we start talking about the gas laws, I want us to talk about the three core properties of the gas. And the three determining properties of the gas are what? Its temperature, its pressure, and what? Its volume. And this gives birth to the three very, very important gas laws. And what are these laws? So what does Boyle's law state? Boyle's law states that what the volume of a given mass of gas is inversely proportional to its pressure, provided that what temperature is kept constant. So mathematically it is expressed as what? The volume is inversely proportional to what? Pressure. The implication of this is that what? If volume is increased, pressure will do what? Decrease. If pressure is increased, volume will what? Decrease, and vice versa. So increment of one causes the decrement of the other, and vice versa. And that's what gives birth to what Boyle's law. Now we all know that what to remove the proportionality sign, we introduce a constant, right? So we can write it as what V being equal to what Kp, where P is where K is a constant. So multiplying this should give us what? That V or PV is equal to what? K. Now this is also what a statement of what? Of the Boyle's law for what? For one case, right? Now for more than one state of the gas, we can have that what? P1, V1 is equal to what? P2, V2, and if you can say have it to be equal to what? P3, V3, as the case may be. These are for what? 3 states of the gas. So if you have 10 states of the gas, the P's and the V will always what? Always what? Equal to what? A given constant. So this is what the statement of Boyle's law. So we are discussing Boyle's law. Now we see that what? Mathematically, Boyle's law can be stated as what? P1, V1 is equal to what? P2, V2 for what? For 2 states of a gas. Now I want to discuss the graph of Boyle's law to show the relationship between what? Pressure and gas as stated in what? In Boyle's law. Let's say we have a graph. Name one side pressure and the other what? Volume. Now know that what? This is what? It's irrespective of the pressure. You can put your volume and your pressure either way and still okay. Now you have your graph like this, like this. Now, this is your graph of what? Of Boyle's law. What does this show? It shows that what? As pressure decreases, what happens to your volume? Your volume decreases and vice versa. Now let's say we have a pressure at this point. At this point. And look at the equation of the pressure here. Let's call this pressure, let's say 10 Pascal, right? And if we trace downwards, you notice you have a what? Let's say we have a volume of what? 2 meter cube. Now, at this point, if we lower the pressure to say 2 Pascal, note what happens to the volume. And we have a volume of say 5 meters cube. So obviously, as what the pressure reduces, the volume does what? Increases. This is a right confirmation of what? Of the statement of Boyle's law that what? They are inversely proportional. Now this is a very, very simple concept to grasp, I guess. But now, what possible questions can be asked from this graph? You can be asked which of the graphs of what? Of the gas laws relates to what? To work done. Which of the graph relates to work done? And that's what? That's Boyle's law. Boyle's law is simply what? A graph of what? Of work done. Now how does that matches? Now, note that what? Boyle's law shows the what? Relationship between what? P and V being equal to what? K. Right? Good. Now it means we are multiplying what? Pressure and volume. Let's see what that will give us. Now recall that what? Pressure is given as what? You have to recall. You recall that what? Pressure is given as what? Force over what? Area. Right? And we have to also recall that what? Volume is what? Volume is what? Length times length times length. Right? By taking a cube for an instance. And this both lengths will give us what? Area. So we can say volume is simply what? area times length. Don't know if I'm clear. Now volume is what? Triple L. For a cube, length times length, or length times breadth times height. It is three dimension of what? Of distances. So volume can be said to be what? Area times what? Length. So what I should pick is that what? Pressure is force over area, while volume is what? Area times length. So let's fix it into this equation. So I'm going to have that what? P is what? Instead of P, I'm going to have what? F over what? A. Instead of my V here, I'm going to have what? A times what? L being equal to what? Now A should cancel what? A. So I have what? Force times what? L. Obviously, L is a distance, right? Length is a distance. So if L is a distance, this simply means what I'm left with is what? Force times what? Distance. And that's what Boyle's law. That's work done, rather. This is what? Work done. So Boyle's law is simply what? An expression of what? Work done by gas. And what does Charles' law state? Charles' law states that what? The volume of a given mass of gas is what? Is directly proportional to what? Its temperature, provided that what? Its pressure is kept constant. So mathematically what we have is that what? The volume of a gas, V, is what? Directly proportional to what? Its temperature, provided that what? Its pressure is kept constant. Now, of course, so remove the proportionality sign was what? Introduce a constant, right? So therefore means that what? V is equal to a constant K multiplied by what? Temperature. Now, consequently, K can be said to be equal to what? V over what? T. So this was an expression of what? Of Charles' law. So for more than one state of this gas, we can say that what? V1 over T1 is equal to what? V2 over what? T2, and it continues. Now, what I want to discuss is what? The graph of Charles' law. Let's see how we can what? Interpret the relationship between what? Volume and temperature at the constant pressure. Now, let's say we have two-line graph. Let one represent temperature and the other represents volume. It doesn't matter the placement of the volume and the temperature. Now, this is a direct proportionality, so it should always be what? It should always be what? A straight line. It should be a straight line. So whenever you hear the word direct proportionality, the graph should be expected to what? A graph of what? Of a straight line. Now, this is very, very clear. If one parameter increases, the other one must also increase. Let's say I pick what? The volume. Let's say 10 meters cubed. Now, if I trace it, I'll have what? Okay. And trace downward, I'll have my temperature at the high point, let's say 20 Kelvin. Now, if I reduce my volume to say 8, let's say 8. Now, notice that what? My temperature reduces, right? So I'll have a temperature lower than the former one. Let's say 15 Kelvin. And if I increase, let's say 12, I trace and trace downwards, I should have, let's say, 25 Kelvin. So it means that what? An increment on one is an increment on the other, and vice versa. Right, we've talked about Boyle's law, we've talked about Charles' law. Next, we want to discuss the general gas equation. All thanks to Charles and Boyle's, all we have to do is what? Just find the mathematical combination of what? Of Boyle's and Charles' law. Now, if you recall from what we've said before, we said Charles' law states that what? The volume of a gas is directly proportional to what? To its temperature at a constant pressure. And Boyle's law states that what? The volume of a gas is directly proportional to what? Its pressure at the constant temperature. So all it took to get the general gas equation is what? To combine these two equations into what? One. Since they all have a common relationship in volume, why don't we make volume one statement express as what? The two conditions. So what we have is that what? That volume is what? Directly proportional to temperature. But this same volume is what? Is inversely proportional to what? To pressure. Now you take my dots here for a modification. So this volume being directly proportional to what temperature, and this volume being what inversely proportional to what to pressure. So this means that what I should have V proportional to what T times 1 should give me what T over what P. Now to remove this proportionality sign, we should what introduce a constant, right? It means V should be equal to what a constant multiplying T over what P. Now when we cross multiply, we should have that what P V equal to what K T. Now if we want to make K the square root of formula as we've been doing, we should have what P V divided both sides by T to be equal to what K. Now for more than one state of this gas, we have that what P1 V1 over T1 is equal to what P2 V2 over T2. Alright, so if you enjoyed the video, please don't forget to give us a like, and if you've not subscribed, make sure you do so. Thanks for watching the video. Bye.